Hey guys, welcome to TUC. This is Abhishek out here. In this lecture, we are going to understand what is a linked list and we will demonstrate it using C language. We are going to cover singly linked list or one-way list. One-way list. A linked list is a linear data structure. The individual elements of a linked list are called nodes. If we think in a technical context, then all the elements of a linked list are nodes and the data is being kept inside the node. When we take a single node, then it should have any number of fields. Out of them, one field should hold the address and another field should hold the info part. Say, for instance, I have taken only two fields, so one field is called the info field and another field is called the next pointer field. Or it's called a link to the next element. So let's divide this the fields of the nodes in two parts. Okay, so it's a dynamic data structure. Why it's dynamic? Because during runtime we can change the size of our list. So if this is node A, this is node B, this is node C, and this is node D. So in this info field we keep the datas, and if node A and node B are supposed to be connected, then we place the address of node B into the link field of node A. Then A and B gets connected, and the connectivity is being shown by the arrow sign. This arrow represents the connectivity between these two nodes. And then when we want B and C to be connected, then we place the address of node C into the link field of node B. So B and C got connected, and it should be represented by an arrow. Well, like this, if we want node D and node C to be connected, then we place the address of node B into the link field of node C. So C and D got connected and it's shown by the arrow sign. If any node supposed to be the last node of the list, then the link field of that node should be marked with a null, and it says that the list terminates over here. So in this case, D is the last node, so the last node should be marked with a null in its link field. So it's a linear arrangement of data. We can also create a two-way list. For that, we need to have two different pointer fields. First field will be the field which will hold the address of its previous node, and third field is the field which will hold the address of the next node, and the middle field is called the info field. This is the previous link, this is the next link, and this is the info field. So apparently we are going to cover a one-way list, and we are going to demonstrate it using C language. So basically the creation of a list can be divided in a three-step process. So first step is to create the nodes, and second step is store the data elements inside the node. elements inside the node, and third step is to link the nodes. So this should be taken as the schematic diagram of a list, and apparently I am considering that I have to create a list of 3 nodes named A, B and C. And for our convenience I am going to put integral data. So well, as I said, it contains 2 different fields, minimum 2 field I am creating. It contains 2 different fields, and all these 2 fields are having all these 2 and both of these 2 fields are different. It doesn't have the same type. So for that, in C we have structure where we can aggregate different kind of data types, which the facility which is not available in array. So a node could be declared as type def struct my list, and in here our info field, this is the information. Well, second field is called the next pointer field. This field is going to hold the address of very next node. So the node, all the nodes are having the same type, and definitely we need a pointer to hold the address of next node which is of its same struct type. So for that there is a self-referential structure in C language which we could use over here. So it could be declared as struct my list asterisk link. This is called self-referential structure. And now the name of the node. We have declared the node in structure. So now the creation of the nodes. So we are going to cover the first part, and the nodes are A, B, C. So node asterisk A equals, well, we have to allocate the memory using malloc. We want to allocate the memory using dynamic memory allocation. So malloc the size of operator. Before working with linked list, we need to have a clear idea of structure, pointers and dynamic memory allocation. And here is the typecasting, because malloc by default returns void asterisk, and if we won't write this thing, then if we don't typecast, then it will throw error like cannot convert void asterisk to node asterisk. So this has been done. This creates the first node. Now we are going to create the second node. So 3 different nodes we have created. This B, this C. The creation of nodes have been done, and now we have to place the data inside the node. Printf, just ask A data is equal to what, like this for all the 3 nodes I am asking. So here scanf mod D. Well, for to place the data in the info field, a arrow info, and here the ampersand. The associativity of this arrow operator is higher than this ampersand operator, so this part is going to be evaluated first, and then the ampersand operator works on the whole part of this a arrow info. So whatever data we are inputting, it will be placed in the memory using this ampersand operator. So the same thing we have to do for the node B and node C. This is done, this for B, and this is for C. So this part has, these two parts have been covered. Now the linking of nodes. So to link the nodes, we have to, we have created 3 nodes. We have created A, B and C. Say we are inputting value 10, value 20 and this value 30. So it's always a good practice whenever we declare the nodes. It's always a good practice to mark the pointer field as null. B null and C equals null. So all these 3 fields we have initialized with null. Now we have created the nodes, placed the data inside the info field of the nodes, and now we have to link the nodes. So in the link field of all the nodes, we have to update something. So for B, if we want B to be connected with A, then we should place the address of node B into the link field of node A. So what should we do? A link equals B. So the address of B has been placed in the link field of node A, and if we want node C to be connected with node B, then we should place the address of node C into node B. So this part is done. Now B link should be updated with C, and the link field of C has already been initialized with null. So there is no need to update any value in the link field of node C. So we have created 3 different nodes. We have placed the data inside the node, and the links in it and the nodes have been interlinked. Now we want to check that whether the links has been the nodes have been linked or not, whether the data is placed inside the node. So printf mod d, wait just a second, for clarity put printf \n/t. So mod d a info. So when we execute this code, we'll get some problem. And what is the problem? We didn't write the corresponding header file of malloc, so it should be written as include stdlib.h. This has been done. So let's check whether it's working or not. G++ -o ab and linked list demo. Let's have a review of our code list. These are the nodes, the initialization of all the link field with null. Now the printf statement asks for the data input. The scanf statement puts the data inside the info field. and this is C. Well, dot slash AB. It's 10. Sorry. It's 10, 20, 30. So the data of A have been. So well, if the nodes have been linked in, then definitely using the node A, we can print the value of node B, the info field of node B. Could it be done? So let's check. A dot A link dot info. This is how we could represent, because a link field of A is holding the address of B. So A arrow link arrow info should represent give us the value which is stored in the info field of node B. So for that, let's check it. It's 10, it's 20, it's 30. It's printing. So like this, we can print the content of any node using the start node. So A here is the start node. So it's going fine. So it's better to use a while loop. It's always good to use a while loop. While A not equal to null, and in here the printf statement mod D this arrow and A. So this prints the content of A, and we are iterating the loop. So A should be updated with link of A, which will advance the pointer to the next node. And for our convenience, for the clear vision that here is the end of the node, end of the list, so printf is null. Is this going to work? Let's check. 10, 20, 30. Well, it's fine, it's working, it's perfect. Well, every time we create the node, and we have to write this big list of the malloc function. So it's good to put this in if we call a function where we can declare our malloc function, it's good. I mean, it will reduce our rework. So let's take it. As we know, this malloc is returning the and malloc returns word asterisk, and we are typecasting it using node asterisk. So right here we are returning node asterisk from the get node function, which is a programmer defined function. So return in here node asterisk malloc and size of. The size of is a compile time unary operator. Size of node. Okay, and wherever we are calling malloc, we should call this underscore get node function, and after the structure declaration we should put its prototype. That's it. And here you can write underscore get node function. we can underscore get node function. Here also we can write the underscore get node function, and similarly right here underscore get node function. So we have called the get node function every time we need to allocate the memory 10, 20, 30. It's working well. See, we have used 3 different names to create 3 nodes. So we can do it using a single name also. So let's take just node A. Using node A, we can create the list. How could it be done? Well, delete all these parts. If node A is representing the first node and node B is going to be placed into the link field, then definitely we could do something like the instead of writing the node B, we can do it as A link is equals underscore get node. This will create node B. I mean, this will create another node where we are putting its address into the link field. So this time no need to link in the fields, link in the nodes. Actually it will automatically create the node and linked also. Okay, so like this, A equals underscore get node. So 3 nodes have been created, and A link info and A link info. So these 3 fields, A info, A link info, A link info. Okay, so there should be a problem over here, and we are going to demonstrate it. So where is the unknown mark? Any problem? This is node A, this is node B, and this is node C. So 3 different nodes have been created. So it's node B, node A, node B, C. So this has been done. And the problem is sometimes when we advance the pointer, then in this case again, if we want to print the linked list, say for example after this iteration, if again we want to print the content of the list, if we want to print the list again, then some problem we would get. Comma A info, and underneath we write the we have written the advancement logic, and printf for our convenience the null value. Okay, so let's see what it's going to print. 10, 20, 30 null. Why? That's because in this iteration the pointer for A has been moved to the till the end. So it's always a good practice to store the start address of the list somewhere, and then say it is a node asterisk t equals a. So whenever we change the whenever we change the content, or we advance or we iterate over, we always update the start node with this temp value. So a equals t. Is it going to work? 10, 20, 30. This is fine, but never change the content of t. So this mode of creation of a list was for basic idea. Now we can also we can create a we can create any number of nodes. The limitation on the number of nodes is not there, because it's a dynamic data structure, and we can put any number of nodes. And dynamic data structure, that means the length of the list, the number of nodes in the list, we can change while during the runtime. So okay, so let's write a full-fledged code. Let's comment this. We are commenting all the parts till here. Okay, so we will take the start node and node asterisk s equals underscore get node. This is our start node, and s link I am updating with null, and in a temp variable, we are updating it by s. Okay, so what is our idea? The logic which we are implementing over here, we are going to take a loop where we will ask every time that whether you want to add the node or not. Depending upon our choice, it will add the node, or it will stop the creation of the node. We will put the data in, and then we will link the node. This is our logic over here. So let's take a while loop. First, let's take this variable c for our choice, where we would store our choice. So while true, in here this the end of while loop, and this is the end of main function, and in here true. Okay, well, we still haven't stored the data into the info field of this start node. So let's ask printf please enter the data for s info. We have asked, and now scanf mod d ampersand s info. We have placed the data in the info field. Now let's ask now we have taken the start node, and we have placed the data inside the info field of the start node. So now we have to ask, like, do you want to add another node? So just ask out, like, to add more node, press y else n. Okay, so This has been done. Now we have to work with getChar function. So before that, it's recommendable to clear the stream. So for that, fpurge, which clears the standard input stream, and its definition is available in hash include stdio underscore ext.h. And then in C we are going to store the choice is done, and further let's do the indentation. And further, the if statement, where we will check the content of if it is n, or if it is smaller n, then break, as we have initialized with the null, or better we do it here as link equals null. So if we don't want to add any other node, so it's better that put into the link field the null value and break from there. If we use break statement, then it will come out from this current loop. So this part is done, and then if the character stored in C is not n, that is if it's y, then we have to create the node. So it can be done as I'm not going to take any new name for the variable, I'm using s itself. So it's s-link underscore get node. This creates a node, and then we don't have to write the linking logic because this has already been linked. The new node which is going to be created when this instruction executes, the in the link field we have placed the address of the new node, because our get node function, we have used the malloc function in our get node function, and the malloc function returns the pointer to the created memory segment, and that address, that memory is going to be placed, that address is going to be placed in the link field of node s. So this part has been done, and then okay, so already s has been created. We are creating any other node which is represented by s link. So when we iterate over, it will come and look for the name s. So it's always a good practice that we update s by s of link, so that there is no any kind of confusion for the compiler. So s equals s link. This has been updated, and when we create the list like this, then s will, at any point of time, s will point till the last node. So if the loop goes over, and every time the nodes are going to be created, the pointer s will get advanced. Initially it was pointing here, and then in the next context it is going to point here, and then in the third time it's going to point here. So we cannot keep track I mean, if we want s if we want to use s to print the content of the linked list, then we cannot get all the data. We'll get only the last data. So that is why I have stored this value of s into this temp variable. So and after the end of this loop, where the loop ends, so there s should be updated by t. Never change the content of t, otherwise we would lose the the start address. So it may be quite complicated for us to keep track of the contents of the list. So while s not equal to null, the same thing what we have done, printf mod d and s info, and then here s equals s link, and outside printf this done. So there is no any problem. It's a beautiful code. And this is the code list, and now we have to check whether it's working properly or not. Int main null, error expected before line 71. If C is printf here is the problem. It's quite minute. This colon and semicolon almost look same, Okay, this is done, and that's fine. Let's check it. Yes, I want to create node. This 20. Yes. 40. Yes. 50. No. It's fine. It's perfect. So this is the approach. According to my view, we can create the list like this. I hope you enjoy, guys. So thank you very much, gentlemen. God bless.